Chapter 3, Jamboree word problems. Just like before, we're going to go slow at the beginning, then at the end I'm just going to be flying through these things. Try the problem on your own. Hit pause after you see it. Figure it out, write it down, try to do it, and then I'll walk through the solution. So here it's saying 4 consecutive integers. So there's 4 in a row. How can we do this? Well, we can call one x, the next one x plus 1. They're not odd integers or even integers, they're just integers. We have x plus 2 and x plus 3. We'll call this the first, second, third, and the 4th consecutive integer. Find 4 consecutive integers such that the sum of the second and 4th, this guy plus this guy, is 3 less than triple the first. Oh my God. So let's write this. The sum of the second and 4th. So let's write this. The sum of the second and 4th is 3 less than, something less 3 less than triple, 3 times, something, the first, x. Alright, the sum. Alright, here we go. So let's combine like terms. X and x is 2x plus 4 equals 3x minus 3. Let's get the x's on one side, right? Let's subtract 2x from both sides. X's are gone from over here. I end up with 4 equals, what do I have? X minus 3. Let's add 3 to both sides, and I get 7 equals x. Alright? So, find 4 consecutive integers. Alright, we're going to find 4 consecutive integers. Here they are. They're 7, 8, 9, 10. Remember, using VESCA, or what is it? No, it's variables, equation, solve, check, answer. Remember, variables, did it, equations, set it up, solve, I solve. Now I have to check before I make sure my final answer. So I'm not done. Let's check. Let's see if this works. Does the sum of the second and 4th, is it, let's see, what's the sum of the second and 4th? It's 18. Is 18 3 less than triple the first, 21 minus 3? Yes, it is, so it worked. So I use my VESCA, variable equation, solve, check, answer. 6 consecutive odd integers whose sum is 0. Oh my goodness. So x plus 2, x plus 4, x plus 6, x plus 8, 1, 2, 3, 4, 5, whoops, x plus 10. Their sum is 0, so I have to add these all up. Equals 0. Alright, 1, 2, 3, 4, 5, 6x plus 2 and 4 is 6 and 6 is 12 and 8 is 20 plus 30 equals 0. Subtract 30 from both sides, right? I get 6x equals negative 30. X equals, divide by 6, negative 5. Let's see if this works. This negative 5, the sum should be 0. Negative 5, negative 3, negative 1, 0, negative 1, 0 wouldn't be the next one. 1, 3, and 5. Will they add up to 0? Let's see. Well, those guys cancel out, those guys cancel out, those. Yes, it worked out. So, let's find the 6 consecutive integers. Here they are. Negative 5, negative 3, negative 1, 1, 3, and 5. They all add up to 0. Wow! Second number is 4 more than triple the first. Ooh, these are number problems. So there's a first, a second, and a third number. So we can make them F, S, and let's see, first, second, and third if you want. Okay? So let's see. The second number is 4 more than triple the first. And the third is 1 less than double the first. Double the first. Find the numbers such that the sum of the second and third, is 7 less than 7 times the first. 7 times the first. My goodness. So I have all these equations. The second number is equals 4 times the triple of the first. Ready? The third one is 1 less than double the first. Note such that the sum of the second and third is 7 less than 7 times the first. I have these three equations. So we're trying to find this, right? Well, we know what's nice here. I have S written in terms of F, T written in terms of F. So I can substitute this S in here, this T in here, and I have one equation, all with one variable, F. So let's rewrite this equation to and substitute. Ready? I'll write, for S, I'm going to write 3F plus 4. Get in the habit of putting these in parentheses when you substitute them, because sometimes there's a subtraction sign, you have to make sure you distribute it through, plus 2F minus 1 equals 7F minus 7. All right, let's add 3F and 2F is 5F plus 3, 7F minus 7. So I'm going to bring this up here and rework it. Right? So I'm going to subtract 5F from both sides. I just went to the lowercase f, so I don't know why. Because usually you deal with lowercase letters. 2F minus 7, add 7 to both sides, I get 2F equals 10. Therefore, F must equal 5. So the first must be 5. Now, V, E, S, C, A. I use my variables, I solve. Now we got to check. But I didn't solve for everything yet. In the solve check, I solved for them all. I found F. Okay? Now I have to find S. S is 3F, so 15 plus 4, which is 19. And T is 2F's minus 1. 5 and 5 is 10 minus 1 is 9. Okay? Now we can double check it. Is it true? Well, we know that these are going to be true. Let's double check and make sure this works. Does S plus T, is 19 plus 9, equal 35 minus 7? 19 and 9 is 28. 35 minus 7 is 28. Yeah, so it works. Here's my numbers. It says find the numbers. You want to find all three. That was problem number 3. We have just enough time probably to do one more. Woohoo! This is a nice one. The sum of 3/4 of a number and 2/3 of the number is the same as 10 more than the number. Find the number. So there's some number. So there's only one number we're talking about. So let's see. The sum of 3/4 of a number. So we have 3/4 of some number. The sum of 3/4 of a number and 2/3 of the number. Is the same as, equals, 10 more than the number. Find the number. Alright, so 3/4 and 2/3. Alright, we can go through, multiply both sides by, what do these go into? 12, to make them all, let's deal with all integers here. So we'll divide this side by 12. This side by 12. 12 divided by 4 is 3 times 3 is 9n. 12 divided by 3 is 4 times 2 is 8n. Is 12n plus 120. 9n and 8n is 17n. Subtract 12n. So n must be, well, how many 5s go into 120? Right? I know we'll get 2 here. 2 times 5 is 10. Get 24. There we go. Alright, that wasn't too bad. And I think I have time for one more. Just enough time. I have 1 minute. Let's see if I can do it. If a number is tripled, then decreased by 5, the result is the same as 9 more than the number. Let's see. So if a number is tripled, then decreased by 5, the result is the same as 9 more than the number. Find the number. Alright, here's our equation. If a number is tripled, then decreased by 5, the result is the same as 9 more than the number. Alright, so subtract n from both sides. I get 2n minus 5 minus add 5 to both sides. I get 2n equals 14. N must equal 7. Let's see. If a number is tripled, then decreased by 5, so 21 minus 5 is 16. Is that result the same as 9 more than 7? What's 9 plus 7? Yes, it is. It worked. VESCA. Have a nice day.